Now is the assignment 9. Here this is a very good example. We have to prove that 1, 2 minus x, 3 plus x square, 4 minus x cube is basis for V, right? So the example is, let V be the vector space of all real polynomials of degree less than equal to 3 together with the zero polynomial over the field R. Here the degree is given to be less than equal to 3. So prove that 1, 2 minus x, 3 plus x square, 4 minus x cube is a basis for V. So when we choose a polynomial from V, we have to keep in mind that the degree should be less than equal to 3. So here also the degree is 3, right? Okay, let's start with the proof. We have to first take the linear combinations of these given polynomials, and I have to show that these are linearly independent. So let me take the scalars to be alpha, beta, gamma. So I'm taking alpha times 1 plus beta times 2 minus x plus gamma times 3 plus x square plus delta 4 minus x cube is equal to 0. To prove the scalars to be linear, to prove the given polynomials to be linearly independent, we always take the linear combinations to be equal to 0. Alright, so then if I add these, I will get alpha plus 2 beta plus 3 gamma plus 4 delta dot 1 minus beta x plus gamma x square minus delta x cube equal to 0. And if you notice that this 1, x, x square, x cube, these are the standard bases for the vector space V, right? And if these are the standard bases, which means these are also linearly independent because these are bases. So can I say that 1x, x square, x cube are linearly independent? Of course. Now because these are linearly independent, so all the scalars are 0. Their coefficients are 0. So which means alpha plus 2 beta plus 3 gamma plus 4 delta is equal to 0. And here beta is also 0 and gamma is also 0 and delta is also equal to 0. Now if beta, gamma, delta is 0, then alpha is also 0, which means all the scalars coming out to be 0, and these are nothing but the coefficients of 1, 2 minus x, 3 plus x square, 4 minus x cube. So all these coefficients, all the scalars are 0, which means these are linearly independent. The polynomials, given polynomials are linearly independent. So 1, 2 minus x, 3 plus x square, 4 minus x cube, these are linearly independent because they are linear combinations with alpha, beta, gamma, delta is equal to 0, implying that alpha, beta, gamma, delta coming out to be 0. So these are linearly independent. Alright, now second thing, the generators, right? These are the generators of V. So for that I have to choose one polynomial. So let me take fx to be equal to, and I should remember that degree should be less than equal to 3. So let me take fx to be a0 plus a1x plus a2x square plus a3x cube belonging to V, right? And fx is also equal to, I'm taking this as, let me take this as alpha, beta, gamma again, okay? So alpha times 1 plus beta times 2 minus x plus gamma times 3 plus x square plus delta times 4 minus x cube, right? So I need the values of alpha, beta, gamma, delta to be in a0, a1, a2, a3, right? And because fx is equal to these two, which means I can compare these, right? I can compare. So from here I can say that alpha is equal to, this a0, right? a0 is equal to alpha plus 2 beta plus 3 gamma plus 4 delta is equal to, This is already not. I'm so sorry. Okay. Then. And then if you compare the coefficient of x, this a1 is equal to minus beta, right? So a1 is equal to minus beta, a2 is equal to gamma, and a3 is equal to minus delta, right? So if you solve this, you will just solve these equations and you will notice that I get the values of alpha, beta, gamma, delta in terms of a0, a1, a2, a3. Just solve them and get the values in terms of a0, a1, a2, a3. And on solving, we get this alpha to be equal to a0 plus 2a1 minus 3a2 plus 4a3, and beta is equal to minus a1. This is clear, right? And gamma is a2, delta is minus a3. Just put these values in over here. You will get the value of this alpha. Just take these to the other side, 2 beta, 3 gamma, 4 delta to the other side. You get the value of alpha in terms of a0, a1, a2, a3. By putting the values of beta, gamma, delta in terms of a1, a2, a3, you get the value of alpha in terms of a0, a1, a2, a3, right? So I'm getting all these values. Now I'm putting these values in star. So after putting these values in star, I get fx to be equal to this. So which means fx is a linear combination of the given polynomials, but fx was arbitrary, right? Which means every element of V is a linear combination of the given polynomials. Which means given polynomials are the generators of vector space V. So from 1 and 2, these two results are proved for the basis. So these given polynomials forms basis for V.